Looking at Module 4, quiz number 1, Henry and his roommate have that friendly wager. So if we want to compare two values coming from different distributions, we compute their z-score or t-score. Z-score if they're coming from a normal distribution, t-score if the distribution is a student t. Both the distributions for Henry's psychology class and for Bob's sociology class are given to be normal distributions. So I'm going to calculate Henry's z-score. I'm going to calculate Bob's z-score. To calculate a z-score, we are basically translating from the distribution, which is normal, mean of 67, standard deviation of 2.5, to the standard normal with mean of 0, standard deviation 1. So the original distribution is bell-shaped. Let's see all the psychology quizzes, mean of 67, mean of all the x's, standard deviation, sigma of all, because that's a population, is 2.5. Notice I use mu for the mean if this is the population of all the grades for his class, and standard deviation sigma for all the grades of the psychology class. But now we want to transform that to the standard normal, so we need to slide it down the axis of grades so that, let's use z for z-scores. This center is 0, the mu of all z's, and then the standard deviation, sigma of all z's, is 1. So we're going to make a transformation, taking that x value from the normal distribution given. We're going to subtract off the mean, I'll just say mu sub x, and divide by the standard deviation, sigma sub x. So that's the transformation that takes the x value. Let's see, Henry made a 70 on the normal distribution given and converts it to his z-score on the standard normal. Notice they're same relative position, just sliding down an axis. So we have Henry's score of 70. We're sliding it down by 67 points. And then we're going to scale the standard deviation so that's now 1. That means we'll divide all the values by 2.5. So putting that into the calculator, make sure that you treat the numerator separately. So I'm going to put 70 minus 67. If I didn't have the parentheses there, then after the division sign, division would come before subtraction, and so we'd get an incorrect value. Dividing by that standard deviation, the z-score is 1.2. In other words, Henry made 1.2 standard deviations above the mean. So that is Henry's standard deviation. I'm going to take Bob's distribution, or his class's distribution, sorry, all their grades, we'll call them Y, and that's in the sociology class. This is a normal distribution with center of 67, but the standard deviation was a little larger. So standard deviation is a little larger of all the Y's, 3, and that center of all the Y's is also 67. We're going to slide it to the standard normal. So the z-score for Bob is going to be his test grade minus the mean of all the grades in his class divided by the standard deviation of all the grades. He also made a 70. The class's average was a 67, but the standard deviation was 3. Both of these are unitless because you have points in the numerator, points in the denominator, giving the z-score is unitless. The z-score for Bob, in parentheses, again 70 minus 67, divided by 3 this time, is 1. And did I get that right? Yeah, 67, 1. All right, that makes sense. That's 3. So Bob is scoring 1 standard deviation above the mean for his class. Henry scored 1.2 standard deviations above But notice his z-score is positive, indicating that he's above the mean. Bob is also above the mean. His z-score is positive, but he is not as many standard deviations above the average as Henry. So Henry would win.